Hello everyone, this is Mr. Lloyd, and today I'm going to the structure and properties test. So let's have a look. So basically the way I broke down this test was I took the 5 main structures, small covalent, giant covalent, ionic, metals and graphite, and then had a question on polymers as well, which is basically how the chapter's broken down, and then there's a really tiny bit on nanoparticles, but I didn't see to put a question on there at the moment. There's probably it'll be like a 2-mark recall question on that. So anyway, the main questions I wanted to promise are the long answer questions that allowed you to show your understanding, so you're able to work it out. So the first one here is ammonia. Has the formula NH3. The diagrams show the electron configurations of nitrogen and hydrogen. So nitrogen, hydrogen. Draw a diagram to show an ammonia molecule for 2 marks. If you want to pause it and try it, off you go. Right, so the mark scheme, I'll go back up to question 1. I'll show you the mark scheme, then I'll show you a picture, because the mark scheme doesn't show a picture. 1 nitrogen joined to 3 hydrogen atoms, correct pairs of electrons. What does that mean? Well, I'll show you a picture of the ammonia molecule. There we go. Here's a good one. So what it's saying is it's a covalent structure. Okay. The clue there is the word molecule. Things with covalent bonds form molecules. You can tell it's a covalent structure from here because the circles are overlapping, the electron shells are overlapping, and there are shared electrons in the overlapping bits. So it's covalent. Other things that you need to know is the hydrogens have 2 electrons in their shared bits because the hydrogen outer shell contains 2 electrons to be full. If you look at the ammonia's electrons, you've got 1, 2, 3, 4, 5, 6, 7, 8. There's 8 electrons. That's because it's the second shell. It needs 8 electrons to be full. So all 4 of these atoms are happy. They've all got full outer shells, and that's how you draw it. Okay. So the clues in the text are NH3. So from that you know there is 1 nitrogen, 3 hydrogens. The diagram shows you that nitrogen has 5 electrons in its outer shell and hydrogen has 1. The word molecule means that it's a covalent bond. And it says you only need to show the electrons from the highest energy level, which means these 2 electrons here don't take part in the bonding. So I have examiner's notes on these. Right, it's not all relevant because I took bits out. No, it's relevant. There wasn't any examiner's mark for that. Fair enough. Let's move on to question 2. Oh, question 1b. Ammonia is a gas at room temperature. Explain why ammonia has a low boiling point. Off you go. Right, mark scheme to that is it is a small molecule or simple molecules, and there are weak forces between the molecules, or the intermolecular forces are weak. So there you go. So you have to say it's small or simple, and there are weak forces between the molecules. The main mistake people make that I didn't give marks for is they said there are weak bonds between the molecules. They're not bonds. The bonds in ammonia are where they're sharing the electrons. These are the bonds. So what we're talking about, the forces. Here's a very good picture. So the bonds here are strong. Oh, this picture is perfect. The bonds here are strong, and the forces between the molecules are weak. They're not bonds. They're just attractive forces. So when you are boiling ammonia, you're not breaking its bonds, you're breaking the intermolecular forces. So there we go. Right, question 2. It's all about graphite. This drill contains an electric motor. The diagram below shows the main parts of an electric motor. This is a picture you might see in physics at some point. So you've got the carbon, goes up there between two magnets. So if you do electromagnetism, the magnetic field will make this spin because of the left-hand rule. It's one of the rules with the hands, the one that goes like that. And since the current's always going to be perpendicular to the magnetic field, it's going to spin and spin and spin and spin and spin. The carbon contacts are made of graphite. Springs push the contacts against the copper ring. The contact conducts electricity to the copper ring. The copper ring rotates rapidly but does not stick or become worn because graphite is soft and slippery. Graphite has properties which are ideal for making the contacts in an electric motor. Explain, in terms of structure and bonding, why graphite has these properties. 5 marks. If you want to give it a go, off you go. Right. Most people got a lot of marks on this. There is a huge list of things to choose from. So in graphite, each carbon is bonded to 3 other carbons. It is in layers. There are weak forces between the layers. The layers can slide over each other. So I was just checking to see, it says it's soft and slippery. 1 electron is not used for bonding. The electrons are delocalized. The electrons carry the charge or current. There is a giant structure. There are covalent bonds. The bonds are strong or a lot of energy is needed to break them. If you talk about ions, you can't get 5 marks, you can only get 4. And, like in some cases in questions like this, if you drew graphite, you could get some marks. If you drew it and showed there were layers, you'd get a mark. If you drew it to show each carbon bonded to 3 others, you get a mark. And if you drew a giant structure, you get a mark. So, like the metals question, the structure of metals question, drawing diagrams doesn't hurt. So here's a good hint. If you're not given a diagram, so in these questions you are given a diagram. In fact, I've just realised that there isn't actually a diagram of graphite right there. So if you basically copied that into that question, you get 3 marks. But if you're not given an atomic diagram, then it won't hurt to draw one. So there's 2 kinds of questions, really. So there is one where you describe a structure and bonding in something, like in metals, which doesn't give you a diagram, and drawing a diagram would help. So let's just skip a bit, just to make sure that you could draw a diagram in the metals one. Doesn't say, but it has done in past questions. So yes. In past questions you are allowed to do it with metal, but it doesn't hurt to draw diagrams. Right, next question. So this was quite an easy question, so I didn't want to make them all hard. So it's about diamond, graphite and silicon dioxide. 2 marks. Can you connect them? Off you go. Right, well, I'm not going to even look at the mark scheme. This is silicon dioxide. The top one is diamond, because all the atoms are the same. Diamond is made of carbon, just carbon, and it's got that structure. This one is silicon dioxide. As you can see, there are 2 different colours, silicon and oxygen. And this one is graphite, because it's layered. So there you go. Complete the sentences using words from the box. Now, I have noticed some people not use the words from the box, and make sure you use the words from the box. Off you go. Right, diamond, graphite and silicon, they all have high melting points because of strong covalent bonds. In diamond, each atom is joined to 4 other atoms. If you're really desperate, you could have counted an atom there. Diamond is used to make cutting tools because it has a rigid structure which makes it very hard, and the element in diamond is carbon, and it gives you a hint. If a diamond is placed in pure oxygen, it makes carbon dioxide. So the oxide bit comes from the oxygen, so the carbon bit must come from carbon. So there we go. I'll just check the mark scheme to see if there's any action. So in that case, 3 lines is 2 marks, 1 or 2 is a mark. If you put more lines, you lose a mark for each extra line. Oh, that's something from exams you need to know. It's called the list principle, which is, say there's a 3-mark question. If you put 4 points and 3 of them are correct and the other one is wrong or contradicts a correct point, then you end up with 2 marks. Every wrong answer loses you a mark. If you put 4 points and they're all correct, but one of them is irrelevant, so the question could be describe the structure and bonding in graphite, and you would say something like graphite is soft and slippery, which is true, but it doesn't get you a mark in that last question because it's in the question. You don't lose the marks. Or you can put C for carbon, the element. Okay, next question is about sodium chloride. Explain why the ions in this lattice stay in place. So it's 3 marks, off you go. Right, so the things you have to say. Sodium ions have a positive charge and chloride ions have a negative charge. Since that's underlined, you have to use the word and, so you have to talk about and sodium and chloride. Don't write chlorine ions. You need to remember that when negative ions, when non-metal elements form ions, they start ending in "ide" instead of their normal name. So it's oxide ions, not oxygen ions, etc. What the arrow carried forward means is, if you say chlorine ions all the time, you'll only lose the mark once. So if you talk about chlorine ions here, and then chlorine ions in the next one, then you'll only lose 1 mark. Ions with opposite charges are attracted, or positive and negatives are attracted, or the sodium and chloride ions are attracted. So there you go. And they're arranged alternatively in each dimension, which is a nice mark because that is actually what you see in the picture. Don't forget to use the information given to you. Question 4. Yes, the answer can be worked out for giving the information in the question. Right, question 5 is about polymers. So 2 marks. Complete the diagram to show the polyethylene molecule. Here you go. Right, all you had to do for this was a line of 4 or more ethene molecules joined to the 2 original with single bonds. So what you needed to do is line, square, line, square, line, square, line, square. Okay. If you did lots of interlinking lines, so each square should only be joined to 2 other squares in between them, but if you did them squares joined to lots of them, I gave you 1 mark. Polyethylene is a polyform addition polymerization. Complete the diagram to show how polyethylene is formed from chloroethene. So they've got an N, they've got chloroethene with its double bond, 3 marks, off you go. Right, the 3 marks are for single bond between the carbon atoms. All atoms correct, as in you've managed to draw 3 hydrogens and a chlorine and 2 carbons. And then the 2 linking bonds, which stick outside. And then the N is now in the bottom right of the bracket. So the bracket is underlined, so I believe what it means is you need to write a bracket. So the reason why the N moves from the beginning there to the bottom right there is because here the molecules are not joined together, so you put the N in front, and here the molecules are joined together, so you put the N to the bottom right. There you go. Right, next question. What is meant by polymerization? 2 marks. Off you go. What does it mean? Many molecules, or many monomers, so you've got to talk about them as many, and then something along the way, joined or linked or and forms a chain. So you've got to say many polymers, so that's why it's called poly. Poly is many, and mono is one, joined. So there you go. Right, last question. Metals. Describe the structure and bonding in metals. 3 marks. Off you go. Right. You get a mark for saying giant structure of atoms or ions, delocalized electrons. There you go. I'm sure if you would have drawn a diagram that would have been fine. The last question, why are they good conductors of electricity? 2 marks. Off you go. Why are metals good conductors of electricity? Electrons, 1 mark, are free or can move, 2nd mark. Okay, that's something interesting about chemistry exams. A single sentence can get you 2 to 4 marks. So you might have done the question which is the 4-mark question about an equation, and all you have to say is copper oxide reacts with sulfuric acid to make copper sulfate and water. That is 4 marks because you've said the reactants, the products, they react. And yeah, I can't remember the 4th mark, but yeah, it's 4 marks for 1 sentence. So don't be afraid to think that you're not writing enough or you've forgotten something, because in chemistry it usually is quite a simple answer. Okay, and there's usually more space than you need because some people out there have huge handwriting, so don't be afraid that you've not left loads of space. So there we go. What were the examiner's marks? This was excellent answers, gave advantages, disadvantages. Oh, there you go. This is the relevant bit. Some people discussed ionic bonding. So there you go. Although part 2 was often correct, which means everybody knows that free electrons are in metals, but most people can't describe the bonding in metals, which means if most people can't do it, and you can, you'll be more likely to get a higher grade, because remember, grades are based on a bell curve, so how well you do compared to everyone else. So there we go, that's a pretty quick video going through the test. I hope that's been helpful, and there we go. Right, I just need to stop. Bye.